Okay, guys, happy Thanksgiving. I'm currently at the Tampa airport. We're gonna work through a couple problems. I'm getting recorded by my friend who's going to New York with me, but I'm very excited. So why don't we jump on in? The other fun part about this is I don't have a calculator. So we're just gonna do our best. I'm probably not going to simplify any of the answers. Like, I'll leave it in final form and your job is to figure out how to plug it into your calculator to get the correct answer. At some point, maybe on the plane or something, I don't know. At some point, I'll go plug it into my graphing calculator and get final answers for you, but I can't do that and record at the same time. So let's try to make this short. These are all coming straight from the review. We're going to start by answering just right triangle trig questions. Remember that this is a review of Unit 5. And yeah, let's go ahead and jump in. So it says given right triangle ABC. So I'm just going to draw you a right triangle. We got A, we got C, we got B. And then it tells you with measure angle A equals 34 degrees and lowercase b equals 10.5. So first remember, capital A is going to be some kind of angle. Lowercase letters are going to be some kind of side length, so keep that in mind. From here, I'm going to go ahead and add to my picture that I now know 34 degrees should go here. And the side length that is across from angle B is your, those are what are corresponding. Angle B is opposite side B. All right, then it tells you find the length of side A. It also says to the nearest tenth, which again, I'm just gonna write out that math and you'll have to plug it into your calculator by yourself. So keep in mind that it's really important that we remember right triangles have a special toolbox. You should know all of those tools. We got sine, cosine, tangent, we got Pythagorean theorem, we got that these two angles that are not right are complementary. From here, because I only need to find this side, I'm going to strategically pick which trig function to use. So I've got this angle. I have side 1, I have side 2. I could go find everything else, but I really won't need to, because if I find the tangent of 34 degrees, that sets up a ratio of the opposite side to the adjacent side. Opposite, again, same idea as before. Opposite, and then the adjacent side is the one right next to it. Okay, I hope you're hearing, I don't know if you can, but you can hear the announcements at TPA right now. Very proud. Excellent. So I need to get A by itself. See how A is just sitting here chilling, but it's not by itself. So I'm going to multiply both sides by 10.5. This is now something that I can plug into a calculator. 10.5 times the tangent of 34. It's going to get me A. And this, for right now, is going to be my final answer. Okay, that'll get me the side length that I want. Now keep in mind, if it says the word solve, you have to find everything about that triangle. So I'd have to find angle B. I'd have to find the hypotenuse using Pythagorean theorem or a different trig function. So be aware, keep that in mind. The next question is simple also. It says given right triangle ABC. So we'll draw us another triangle. A, B, C. Doesn't really matter. As I usually put C at that right angle so that I could name the hypotenuse C. That's just habit from the Pythagorean theorem, but it's really not a big deal where you put A and B. So long as you're consistent, aka if angle A is over here, side A needs to be over there. Then it tells you side A, lowercase a, is 12.3. Side B is 31.6. I'm going to put that on my diagram. Across from A goes 12.3. Across from B goes 31.6. Okay, and then it asks you angle of B. So in my head, I'm sitting here saying, I need some kind of trig function that's going to get me this angle. And I notice what's given to me. So again, tangent's going to be helpful here. If I set tangent of B equal to the ratio of the opposite side to the adjacent side, I can start to solve, but here's the tricky part. B is almost by itself. You've got this trig ratio here, or trig function here that needs to get rid of. And I keep asking you, if you hear me say something like, what's the opposite operation? What's the inverse operation to tangent? I'm looking for inverse tangent. If I take the inverse tangent of both sides, that'll cancel out the function that is being operated on. Like the angle B is being operated on by tangent. So inverse tangent undoes that. So B is the same thing as the inverse tangent of 31.6 divided by 12.3. Again, now something I would plug into a calculator. Keep in mind that in this section of your test, you will want your calculator, I'll write that out real quick. You want your calculator to be in degrees at this point. Unless stated otherwise, I think I'll say that. Oops, that looks silly. Unless stated otherwise. Sorry about the chicken scratch there. But 90% of the time, when you're finding an angle measure and it's getting towards that real-world application section, when you're in chapter... Do you hear the dogs? Wow. I hope you heard that. That was fantastic. Oh, still going. Fantastic. I'm really sorry. This is just funny. When you're looking at Unit 5 and in Chapter 8, a lot of it's more realistic. It's more real-world application. So that's where you're going to be using degrees more than radians. But in your graphing and in every other unit we've done so far, we've really been working in radians. So keep in mind you'll have to change that back and forth. Just be looking at the question to see what it actually asks you to do. Okay, so that's right triangle trig. I have a couple more things I want to remind us of here. For right triangle trig, and for Unit 5 in general, you've got a couple other things you got to make sure you know. Law of sines and law of cosines, like this. Okay, so your law of sines, we could go back through that derivation, but I know you don't want to. We got sine of angle A is divided by A. Sine of angle B divided by B. Sine of angle C divided by C. Any triangle at any point, but this is when we have so many angles. You've got to have something like ASA or AAS to use law of sines appropriately. Now, you are able to use, I'm going to put an asterisk up here. I hope you can see that. I'll put an asterisk right here. That says you can use it for SSA with exceptions. So sometimes you use it with SSA, and sometimes you get a triangle, sometimes you don't. Sometimes you get more than one, sometimes you can have two triangles. So you've got to be careful if it's SSA, but these two are always guaranteed. Law of cosines is when you have more sides than angles, and you've got something like this. B squared plus C squared minus 2bc cosine A. And this does not have to be the hypotenuse. It can be any side, so long as you're using the other two sides and the angle across from A. So notice that correspondence there. All right, let's do one or two of these real quick. It says solve triangle ABC given. So I'm going to draw myself a nice not right triangle. Name this A, B, C. A is 41 degrees. C is 77. I know my diagram doesn't look like that, but that's all right. And B, no, I'm sorry, and then side A is 10.5. So that's all given to you. It just says that in words, kind of like the other page did. It wants the solving of the triangle, so it's really easy to find angle B by setting up the fact that all angles of a triangle add up to 180. Subtract 77, subtract 41. Oof, I gotta do this mental math, that's dangerous. 77 and 41, you can see me on the side, I bet. 8, you got 11, and then you're going to take that away from 180. Sounds like 62. Yep, all right, 62 degrees is angle B. So I'm already one step of the way there. I have one side, I have all three angles, I have so many angles, so I'm going to use law of sines. Law of sines would say sine of 62 over b is sine of 41 over a. Now I did pick 41 strategically because if I picked 77, I wouldn't have that side length. Again, this is where my handy dandy calculator is going to help me out a lot. I would have b sine 41 equals 10.5 sine 62. Now I would divide by sine 41. Okay, that simplifies, and now I have letter B is equal to whatever the heck that number is going to be. Now, as I'm mentally checking my work, I should be getting a value. If I just found lowercase b, I should be getting a value that's bigger than 10.5. Each of the angle measures corresponds with how large the side across from it is. So 41 is the smallest side. 41 is the smallest angle, resulting in the smallest side. Same thing here. And then you should have the largest number across from 77. I know my diagram isn't very accurate, but that concept of checking your work with that number sense is really important. You'll save yourself from a lot of mistakes that way. Okay, let's just find C real quick. We can set up the exact same thing. We should have enough room for me to write down here. I've got sine of 77 over C is supposed to be sine of 41 over 10.5. It's a good idea to keep sine of 41 involved because this had no rounding in it. This answer, whatever I get per V, will be rounded, and that's a little bit more dangerous to use. I might mess something up. I might type something in wrong. So if I use my original answer here, I'll probably, I've saved myself from that problem of accidentally writing the wrong answer. So let me just finish this up real quick. And you would then solve for C by dividing by sine of 41. Again, something you can plug into a calculator. I'll write that over here on the side here. We got 10.5 sine of 77 divided by sine of 41. So that's a law of sines practice. All right, let's do one really quick of law of cosines. Law of cosines. You're going to have triangle ABC. Triangle ABC, you are given that A is 5. You are given that C is 8. And you are given that capital B, or angle B, is 77. Doesn't that sound familiar? Now it asks you to solve the triangle, but really, I most want this, because I want to practice my law of cosines. Now keep in mind, this was the formula you're given. I don't know if you can see that. I'll scoot it down a little bit. B squared plus C squared minus 2BC cosine A. But that doesn't mean I have to have the side A. I can use whatever variable here, so long as I have the opposite angle to it. So notice, I have that angle. So that's how I'm going to set up this formula. I'm going to say that this is B squared equals side 1 plus side 2 minus 2 side 1, side 2, cosine of the angle across from the side over here. And that is straight up something that you can plug into a calculator. Now I'll do one part of it for you because one, it's not too bad, and two, I've seen this mistake happen over and over and over and over again at this point. You'll say 25 plus 64, then you'll subtract 80 as if you're allowed to do that, and then figure out something with this cosine 77. 80 is tied to the cosine 77. These are multiplied together. So it's like saying that that's 80x, and I'm trying to combine it with that. That doesn't make any sense. So what you can do is you can combine 26 and 64. So I'm sorry, 25 and 64. That's 89, 81, 89. Wow, numbers. I'm on break. Don't give me too much of slack here. There you go. That's something I would plug into a calculator. I have no idea what it is. And then I would say, wait, hang on. B is currently squared, so my final answer would be the square root of whatever that is. Okay, just a little bit of law cosines practice. Okay, be very, very careful. Let's do the area of this triangle real quick. The next question actually literally says find the area of this triangle. And you have some options. I have side, angle, side, and there's a formula for that. That secondary formula that we have is 1/2 B or AB sine C. Now, again, I'm using these arbitrarily. I don't have sines, or I don't even have the angle C. But I can use this so long as those are in order. Like I can have A, B, as long as sine C is the one that's in the middle of those two. So I'm going to put in parentheses here. This is SAS. It has to be the included angle. So I can say 1/2 times 8 times 5 times sine 77. It's the angle in the middle. It's called the included angle. Okay, so this is two sides with an included angle. This is something, again, that I can plug into a calculator. Looks like 20 sine 77, and whatever that answer is, I would get as the area of the function. Neat. Okay, there's a lot more that I would want to go through with you guys, but today I'm going to go ahead and wrap it up. I might be able to make another one either right before the end of break, or let's see if I get some kind of time in New York, but I'm not counting on it. I do want you to make sure you're ready to deal with bearings. We practiced this in class, so I would double check your bell work on that. That's honestly the biggest thing that we didn't just talk about. There's a lot of other things that we could practice. I'll just show it here on the camera real quick. This is part of the review, something that I didn't get the chance to post to your EDSB. I might still be able to while I'm sitting here working, but these questions at the very bottom are the word problems that you might want to practice. I'm actually going to zoom in right there. So if you get the chance, these are good practice problems. I have some of them already worked out, but others of them I don't. This one should look familiar to you if you're in class before we left. And if you notice, this one and this one, 38 and 40, both have to do with bearings. So it's a good idea to practice all that. Okay, and I'm noticing that I'm at right about 15 minutes, so I do want to go ahead and pause. That's what we talked about. You should be ready for your test when we come back. I hope you are enjoying your break. I hope you have an excellent day. I hope you get the chance to work through these problems that we worked on together. I hope you have a safe and happy break, and I will see you very, very soon. Keep an eye out on Thanksgiving Day if you get the chance. You'll see us in those really ugly white hats. All right. I'll talk to you guys soon. Be safe. Bye-bye.